Now let's start with question 4. As you can see, the question belongs to a section of electromagnetism. A solid metal cube of edge length 2 cm was moving with positive y direction at a constant speed of 6 meter per second. There is uniform magnetic field of 0.1 Tesla in positive z direction. The potential difference between the two faces of the cube perpendicular to x-axis is. So basically there is two important points. One is the uniform magnetic field, and there should be an electric field as well, so that the net force balances out, and in that case the speed can be constant. So let's see the solution here, friends. Right. So as you can see here, the magnetic field given to us is 0.1 Tesla, which is along positive z direction. So magnetic field would be here, right? The cube is moving along this direction, 6 meter per second, right? Now let us mark the coordinates here. This would be x-axis, this would be y-axis, and this would be z-axis. What we want is, we need this face and this face which are perpendicular to x-axis, and we need the potential difference between these two, right? For that, so that means there will be some electric field along x-axis, maybe positive or negative, which will help us to find the potential difference in here, right? So as per the question, definitely the electric field will be in minus x-axis, that is minus I cap, magnetic field along positive z cap, so that E cross B can give us the velocity. In this case, the very important foremost point is that QE should be equal to QVB. From this you will get E is equals to VB, right? And delta V, the potential difference, would be equals to E into the displacement. So what is the field here? 6 into B is equals to 0.1, that would be 0.6 Newton per coulomb. This is the electric field, and the delta V, that is the potential difference, I am talking about the magnitude, it would be 0.6 into the length is 0.02 meters, right? So this you will get to be as 12 into 10 to power minus 3 volts. So let's see what is the best option for this question. As you can understand from the options, option number 1 is the best answer for this question. Now let's move ahead for question number 5. Now this question here belongs to a section of optics, that is ray optics. The question says a plano-convex lens of refractive index, this plano-convex refractive index mu1 has focal length f1, is kept in contact with a plano-concave lens of refractive index mu2 and focal length f2. If the radius of curvature of their spherical faces is r, where f1 and f2 hold this relation by the magnitude, then mu1 and mu2 are related as. So let's see the solution. Now as you are well aware with this formula, that mu minus 1, 1 by r1 minus 1 by r2. For plano-convex lens, this formula will be written as mu minus 1, 1 by r, right? Now if this is 1, let's take this as 1. And similar case for the second lens as well. If I say, then 1 upon f2 would be equal to mu2 minus 1 into 1 by r again. Now just take the ratio of these two. Let's take this as equation 1 and this as equation 2. So you get this as mu1 minus 1 by mu2 minus 1. As per the details given in the question, that f1 is twice of f2, what you will get is 1 upon 2. Thus solving, you will get 2 mu1 minus 2 would be equal to mu2 minus 1. From solving, you will get twice of mu1 minus mu2 is equals to 1. Let's see which is the best relation for this. So you can understand that first option exactly matches our requirement. So answer to this question would be option 1, right? Let's move ahead and see our next question. Now this question belongs to a section of modern physics from the chapter nuclei. Using a nuclear counter, the count rate of emitted particles from a radioactive source is measured. At t equals to 0, the count was 1600 counts per second. So this is the activity. At t equals to 8 seconds, it was 100 counts. That means there was decay. The count rate observed at t equals to 6 is required. So let's start with the solution. So basically the count rate depends on the number of particles. So I have a formula, this n equals to n naught 1 by 2 power n, where n is equals to given time divided by half-life of the particle, right? So as per the first statement given in the question that the count decreased from 1600 to 100 in 8 seconds, let's find the half-life of this sample. So 100 is equals to 1600 1 by 2 power n. Comparing from here, n equals to 4, which is equals to t upon t half, right? What is the time given? 8 seconds. What would be the t half? So simply t half would be 2 seconds, right? Now, let's take the next case. N dash is equals to n naught into 1 by 2 n dash. And this time I have to take time as 6 seconds and we have to find what would be the number here. So this is 1600 1 by 2. What is the value of n dash? 6 by 2. And when you solve this, you will get 1600 into 1 by 8. So certainly this n dash will be equals to 200. Let's see which is the best suited option here. Apart from the 4 options given, option number 4 is the correct answer, right? So let's move on to the next question, that is question number 7.